Okay, so this is over types of reactions. So we are learning 5 types right now. There's a few more than 5 in your notes, but we're going to learn the basic 5. So the first one we're going to learn is a synthesis reaction. And so whenever you think of synthesis, there may be a couple of things that come to mind, but a lot of kids typically say that they think of photosynthesis, which is great. Photosynthesis is essentially the same thing. You're taking all the ingredients a plant needs, so sunlight, carbon dioxide, water, those kinds of things, and you're combining them all together to form energy. And so a synthesis reaction is just that. You're taking multiple things and you're combining them to form one thing. So we have a generic formula, so we always do these A plus B's. There's no element A on the periodic table or B, and so it's kind of just a generic, hey, this is what it is every time. So if I have a single thing plus another single thing, that's always going to be combined, because if I have 2 single things, the only thing I can do is combine them. And so it's always going to form just one single product. And so then what some examples would be like sodium and chlorine. I want to point out that chlorine has a 2 here. 1, because it's Brinkelhoff, so it's a diatomic molecule. But 2, it's still just pure chlorine. Just because there's a 2 here doesn't mean that it's no longer a single thing. It's just chlorine. It's only one type of atom. It's only one element. That's what we're talking about here. So one pure element substance combines to form a compound. And so we have sodium plus chlorine equals sodium chloride. Then we have hydrogen gas plus oxygen gas gives you water. And so down here, magnesium plus phosphorus. So we could predict the products, right? Again, whenever you're doing product predictions or whenever you're doing anything like this, when we're combining things, we always have to think about what we learned with bonding. And so I have to think about both their charges. So magnesium's charge is +2 and phosphorus's charge is -3. And so I need them to cancel out. So I'm going to need the thing that 2 and 3 have in common is 6. So I'm going to need to make magnesium get to 6, which would be 3 of them, and phosphorus to get to 6, which would be 2 of them. And so they cancel out. So I have Mg3P2. But either way, they're still combining to form just one thing. And so that's how a synthesis reaction works. So decomposition is the next one. And decomposition is essentially the same thing as synthesis, just backwards. So we can take all of these and just flip them backwards, including our generic formula. So AB is decomposing down to A plus B. And we know that decomposition means just breaking down. Whenever something's decomposing, it's breaking down. So we're just going to take this one compound and break it down. And a decomposition reaction, you always have only one reactant. That's it, because it needs to break apart. You can't have multiples, because then they want to react too, and that's no longer a decomposition. And so you could literally take the same problems, and if you just flip-flop them, they become a decomposition. So sodium chloride can break down into sodium and chlorine. Water can break down into hydrogen gas and oxygen gas. And magnesium phosphide can break down into magnesium and phosphorus. And so that's a decomposition reaction. So it's just breaking apart. I'm taking one thing and it breaks apart into its smaller pieces. Okay, so next up would be a combustion reaction. And now keep in mind, all of these you do need a balance. None of them have been balanced, and so you always need to make sure that after you write the equation, you are balancing them. So a combustion reaction is always going to be some sort of carbon-hydrogen mixture. So we could have any ratio of carbon and hydrogen. I could have 2 carbons and 6 hydrogens, 1 carbon and 4 hydrogens, 6 carbons, 6 hydrogens. It doesn't matter. You have some sort of carbon-hydrogen mixture. But a combustion reaction is essentially lighting something on fire. And so we always fire needs oxygen. So it's always going to be oxygen. And then it's always going to produce carbon dioxide and water. It's what it's always going to produce. It's carbon dioxide and water. So this is the generic formula. So some examples so you can see, we have methane, and I'm going to still have oxygen and then carbon dioxide and water. That's not changing. So the only thing that changed is just the first thing. All of this is standard combustion and will never change for combustion reactions. And so then you have benzene, which would still be carbon dioxide and water. I could have propane, still just carbon dioxide and water. So this last part doesn't change. If you can see that every single time, the only thing that's changing is the beginning thing, whatever we are burning. But when we burn it, we always need oxygen and we're always gonna produce the same thing. So that's a combustion reaction. I'm gonna do single displacement and double displacement on a separate video.